So welcome everyone. My name is Emmanuel Severin, and I'm thrilled to be starting this webinar on building a multilingual voice assistant in 10 days. So there are three elements in this title. There is multilingual, there is voice, and there is 10 days, so speed. And we'll talk about how those three elements, multilinguality, voice, and speed, add to the complexity, but also why most companies need those three of them, the three elements combined, to be able to add value for their customers. To start, let me begin by introducing myself and introducing the other participants. So my name is Emmanuel Severin. I'm a product manager at PolyAI. And I'm thrilled to be here with Ivan Vulic, who's a researcher at the University of Cambridge and also working with us at PolyAI, as well as Anita Yakimovska, who will give us the perspective on this issue from a successful company, DT. And together, the three of us, we're hoping to be able to give you a bit of a round and multifaceted perspective on this topic. So let me start by setting the tone and kind of explaining again, why does it matter? Why is this topic of multilinguality for voice assistant coming on most of enterprises' agenda? Well, to begin with, it's really about growth. All companies need to grow, and growth required finding new customers. And very often, new customers are in new geographies or speak another language. In general, speak another language than the one that the company is used to serving. So this takes place in a few different ways. One of those ways is, for example, for a company like DT, which is expanding to new countries, and that means serving customers in a new set of languages than the company was serving before. Or we also see companies staying in one geography, but then trying to address new customers in that geography, and that means being able to serve them in another language. So, for example, in the US, Chinese and English, or Spanish and English. This is a topic that we see come up regularly. So one way or another, those companies are saying, how can we serve people in whatever language they speak and still provide them a great customer experience? And once that's set, we also see that most companies don't want to invest into different capabilities for different languages. So they want to have one voice assistant that can serve all those languages. They don't want to maintain and go through the procurement process and the integration process and the setup process of policy and NLU and all of the rest for multiple languages in parallel. They want to have go through the effort once and then being able to serve customers in any language that they choose to speak. So this is really the generic perspective of why do we see this set of challenges. But to give maybe a more specific perspective, I'll ask Anita to provide her view on the challenges and opportunity from DT side.
Thank you, Emmanuel. Hello, everyone. Good morning from Bonn, Germany, from the headquarters of Deutsche Telekom. Deutsche Telekom, as you know, it's one of the biggest telcos in Europe. And by that, under the umbrella of Deutsche Telekom, there are quite a few Central and Southeast European countries involved. So I am a part of the business product team in the Europe section of Deutsche Telekom, and I am a part of the One App project. So as the name mentions, the One App project actually is a unified solution of a mobile application that we have across all or most our national companies under the umbrella of Deutsche Telekom. So that means that we want to promote the app as the main self-care channel that our users can actually use. So now we have about 60% of our smartphone base on our One App. So we are looking into new ways for monetizing. But before we actually want to monetize, as I mentioned, we like to have this channel as the main self-care channel. That means providing the best self-care solutions that we can actually achieve. And because we are involved with so many different countries, so many different languages inside a country, different dialects, etc., on our roadmap, we have actually first a text or an NLP chatbot, and then go to voicification eventually. In some countries which are like more mature when it comes to the solutions that we can actually use, or they use a high resource language, so to speak, like German or Polish, those countries are more mature to go forward to the voicification, for example. And that actually brings us to one of our main KPIs, which is call deflection. So we want to deflect calls from our call centers and actually provide the best self-care solution on our app as the main self-care channel. But it is very much not that easy to actually do this, because as I mentioned, some languages are more mature into getting the solution, some are not. And implementing a language agnostic solution actually provides a unified solution to the problem and answers to some of the challenges that we have across all of these different territories, and that is actually providing a unified customer service. We don't want different solutions in production in each and every national company, because we then lose the unified experience when it comes to the self-care. So when it comes to also that challenge, we want to promote the best brand experience as well on the app, and that can be mostly provided with one solution across all these territories. So as I said, we have a base of 60% of our smartphone services in Deutsche Telekom on this application. So how can we actually use this in our advantage in promoting the best self-care possible in all the languages respected in all of the countries? And on top of that, actually deflect calls from our call centers that actually provides millions and millions of euros in the cost savings. So how to actually tackle some of these challenges, more on that would be covered by Ivan.
Hi, hello everyone. Yeah, nice to meet you via Zoom, and I'm really happy to be here and talk about multilinguality in conversational AI, in the actual conversational AI systems. One reason for that is because I also spent years and years researching these multilingual models from the more academic perspective, and wearing this academic hat. And it's really great that some of the ideas that we actually had along the years are now integrated into some of the solutions. But before I go to some of the solutions and design ideas, I still want to talk a bit more about technical challenges, which were listed here. And yeah, we can start from maybe the basic ones. So do you actually need multilinguality at all? So many companies, many businesses, they first start having their business by having only English as the only language in their minds, and they optimize all the systems for English. And it's actually English could be seen as the easiest language in a sense, because there are so many major technology and resources which already exist for English. And yeah, if you work in English, you already have a lot of data, you have a lot of speakers who could help you annotate the data, etc. But if you kind of optimize your solutions to be too English specific, if you at a certain point decide to expand your technology to other languages, it might be too difficult to start from something that already strayed away too far by doing English-centric modeling only. So if the company wants to build a truly multilingual solution, it's very important to actually start thinking about that from the very start. And one of the reasons, or the main reason, why PolyAI has been named that way is because poly stands for polyglot. So we always wanted to do some major breakthroughs in the field of multilinguality. Talking a bit more about English and all these high resource languages, as Anita already said, not all languages are created equal. And what actually happens is that if we continue building systems only for high resource languages, many of the other languages are left behind. And what is left behind with leaving behind those languages are also speakers of those languages, which basically means if we transform our society in a digital way, that many speakers of minor languages might not get equitable digital access to technology. So apart from the fact that speaking more languages for a conversational system actually means reaching more users, there is also this profound, call it societal, democratic aspect of working in multilinguality, which is enabling and bringing language technology to more people and really moving towards a digital multilingual revolution of the digital world. But of course, another challenge when we work with other languages is what we call data sparsity and data scarcity, which means that like machine learning models, for example, they work only if they have quality data, and we don't have that data for lower resource languages. So one of the critical challenges is also how to procure the data, how to annotate it, and maybe how to also leverage some of the data from high resource languages to help build better models in low resource languages. Another fundamental challenge is moving from text to voice, and this is why voice is the integral part of our webinar. And basically, when it comes to really handling speech and voice, there are so many different challenges that arise from the fact that people actually speak with different dialects, and there are many non-native L2 speakers of certain languages. For example, I'm not a native speaker of English, so I also do a lot of pronunciation mistakes when I speak English, and the system should be robust and it should adapt to all these different and non-native dialects and also different native dialects of the same language. So it's just speaking about English, you have so many different ways of speaking English from the US over Europe to the Far East and India, etc. And yeah, how to handle these speech recognition errors is a major challenge. And finally, one important aspect is what we call consistency, which basically means that if you want your solutions to work in multiple languages, then a much better design choice is to have one integrated solution that can work really well across many languages at once without having to do major changes when you want to add a new language, etc. Because if we develop a particular dedicated system for every single language, it also means that any change in our logic of conversation or any change that we want to implement across the board has to be implemented one by one for every single system, which might actually make all these systems incompatible between each other, and we might have problems with consistency of the systems. So yeah, so those are some of the challenges that we detected working on those systems, and how we actually tackle them will be covered in the next few slides. Okay, yeah, next slide, please. So this is what we see here is a very basic high-level overview of the main design that aims towards these integrated multilingual solutions. And basically, one important aspect is deciding what has to be language dependent and what has to be language independent. So this is a standard pipeline where voice from the user goes in. We need to understand what the user actually says and what the user wants, what the user's intent is. Which is done by the natural language understanding module. And of course, this module should be language dependent because this is something that we don't really control, because users can speak in many different ways. They speak many different languages. So we need to somehow capture the semantics of that utterances and capture those intents from their utterances. And if we want to optimize the capture of semantics for different languages, of course, that we kind of need to adapt our systems to be really good in capturing those semantics in those languages. And on the right side is the language independent policy module, which is something that we control. And this is actually the logic of the conversation. So this is where we define how the conversation flows will look like and how our systems will act and react to what the users actually say. And really, although this sounds quite simple, this differentiation between the language-independent NLU and language-independent logic is quite crucial to actually build those integrated multilingual systems. And another reason why we want a language-independent policy is also if you have your, for example, customer support services in many different languages, then particular services in particular languages can define a slight changes to that policy, and the system will still work really well. So if you want to add some extra conversation flow, or you want to slightly tweak the behavior of the system, it is still possible without really making any major restructurings of the entire solution. So in the next slide, we're going to delve deeper into the actual pipeline. So again, the pipeline starts with having the user interacting with the system in their native language. So the module that then comes next, and which is one of the core modules which needs to address this fundamental challenge of people speaking with different accents and dialects, is the multilingual automatic speech recognition module. And basically, the main role of that module is to like quotation mark translate speech to text, and then we can actually apply our natural language processing models, multilingual models, on top of the transcribed text. So we're going to talk more about ASR on the next slide, but here let's focus on capturing these intent, the semantics of the user's utterances. So the main idea is basically to create representations that actually work in a way that no matter how users actually express their intent, and they can talk in many different ways, we can actually map them to a particular latent concept which lives in a hyperdimensional space. So for example, in the banking domain, the users can actually say that they can't log into their account in so many different ways, only in English. So if we have users who are speakers of Chinese, they will speak in Chinese, and they will say pretty much the same thing. So the main intent is still the same. They still want to complain that they can't log in into their account. And so what we actually want is a multilingual representation model, which is part of the multilingual natural language understanding, which will create these machine-readable representations and extract the accurate intent or this latent concept from the user utterance, which is pretty semantically variable. And then the utterances from different languages, the utterances from the same language will occupy very similar points in this hyperdimensional space when we encode them from text to these machine-readable representations. So that's the main idea of the NLU module in multilingual setups. And if we have a Spanish query in the banking domain, which is more about the credit limit, we will do the same thing. So we will encode it into this point in the hyperdimensional space. But the idea is then that this point will occupy a different subspace of the whole space, which will be further away from the subspace occupied by the login account latent concept. So the idea is basically to translate different ways of how people speak about particular intents into these universal latent concepts, universal intents that live in this hyperdimensional space. And this is the information that we get from the user that gets fed into the policy module, and we have this essential information, and we can then decide what to do and how to continue with the conversation flow once we get this integral information from the user. And then the final step on this diagram and also in our conversational system is, of course, reacting to the user's utterance and bring back the spoken response of the system, which drives the conversation forward. So that's the main idea behind the architecture. So I mentioned that one of the fundamental challenges is really how to handle speech recognition, and basically we spent a lot of time trying to figure out the best possible set of steps, and we roughly divided it here into three phases called pre-processing, then applying the actual speech recognition models, and then the post-processing phase. And at each phase we have a set of critical blocks that actually help us to get our performance to really high really high results that actually enables us to build all these multilingual systems. And so one of the critical challenges is accent neutralization, and how to do that is basically creating models that are more robust to accents by also collecting data in different accents of the same language, and further to apply some of the denoising solutions, because what you often also have talking to the system is some issues, that noise that arises from the fact that people actually speak what we call in the wild. So you will have some background noises, you will have some telephony problems, etc. And this is all something that has to be handled before applying the actual ASR models. Another thing that we do is the so-called biasing, which is basically driving the ASR models, if they're uncertain about certain transcriptions, to steer them towards more plausible solutions. And when we actually talk about different domains, it might be that the client actually has some particular brand names or particular semantics that has to be captured by our models, and we know that in advance. So the idea there is to basically just steer the model to, if it is uncertain, to capture and to recognize these particular in-domain terms as more probable than something that is more from the general language. Then when we apply ASR models in multilingual setups, we don't have to really constrain ourselves to having a single model, because what we often know from machine learning literature is that combining or ensembling different machine learning models typically leads to better solutions, because we can get to better results by doing voting of different models, or combining their predictions, or even optimizing them jointly via training. So this is also something that we do at the level of ASR models. And finally, at the post-processing stage, we can also combine different predictions. So maybe we don't have to learn only from the top one selection of the ASR models. We can keep top n, and then try to also use the best of that so-called n best list to have even better recognitions. And yeah, so to come from the n best list towards the final result, we also have some aggregation models as part of the post-processing scheme. And so you can see that already the ASR model is pretty complex, and this is only the first part of the pipeline. So moving from ASR to NLU, which is on the next slide. Yeah, so for NLU, we also have our proprietary solution called Convert. And the idea, so I mentioned that the idea here is to translate user speech, user sentences into these universal latent concepts, universal intents. And in order to actually do that, we kind of need to understand language in a sense that we need to capture all these subtleties and peculiarities of how people speak into the parameters of a large machine learning model. And in order to do that, we trained a cutting-edge, state-of-the-art transformer-based model on the entire Reddit, which is almost 4 billion comments, which contains all these intricacies of language, including noisy language and informal use of language, different slangs, even different ways of speaking, like different genres as well. Another important thing with Reddit is that it also has this natural conversational structure, because it's in the shape of an online forum where people respond to other people's questions, and they can actually delve into a discussion which really resembles the actual conversation. So what our model does is it learns to respond, which is exactly the most natural task to learn with a machine learning model when it comes to conversational AI. Another important aspect of Reddit is the fact that it actually contains data in many different languages beyond English, which means that the model implicitly learns to converse also in those other languages, which is essential to build our multilingual solution. And we're really careful and really creative in designing this Convert model, which finally yielded a really efficient and great performing model, actually, which currently has leading results on the market when it comes exactly to the task that we care about, which is this multilingual intent capture. So basically, the main idea is then to pre-train the model on this large data set, so that the model gets this common sense, like general purpose language in a sense, so that it understands its general language. And then when you go to the particular sectors, to the particular domains, you can just slightly fine-tune the model with some in-domain data to optimize it to become better for capturing semantics for these particular domains. So if the model has the common sense of language in general, if you have a banking domain, or if you have a telco domain, you can feed some in-domain data and get it to start working really well in the telco domain. So that's the main idea behind this pre-training plus in-domain fine-tuning regime that we apply currently in our multilingual solutions. And that's all for me. So I'll give the floor to Emmanuel.
Thanks, Ivan. Yes, so this is an overview of the performance of the of our system in a few different languages, some of the top European languages. And we evaluated the model by asking people, native speakers from those different countries, to call our agent and try to express a typical banking intent. I would like to open a new bank account. I want to get my statement, etc. In their native language, and evaluating how performing we were in terms of understanding it. So we had 80 languages that were evaluated, again, one out of the box, and then after 2 weeks of data. And some of the key takeaways that I see from this results is, one, the performance is good after out of the box, but it's really shining after 2 weeks of performance. And it speaks to the value add of giving the models a few weeks to learn from real world data. In terms of helping agents learn, nothing beats real data in terms of how people actually say things and how models can learn from it. And this is a confirmation of what we see here. The other learning that I take from this exercise is just how relatively equivalent the performance can be with the right infrastructure across all languages. So we see here that it's not English shining and everything else below. It's like strong performance across all languages. And I think it speaks to, again, with the right infrastructure, with the right ASI model and the new model, you can really have something that can work well across most languages. You don't need to have something that is, shining in English and then really underperforming in those other languages. So this is an overview of the languages, for example, that we're able to cover in our, with our infrastructure, and it's just a running list. For example, we had discussions a few weeks ago about adding Catalan and Romanian into this list, which is something that we can also do. Again, once you build the fundamental building blocks and the infrastructure with the ASR, the NLU, the policy to be able to handle any language, it's relatively easy to then add to them. And you can relatively flexibly adjust to whatever context you need to deploy, and then you can say, okay, I'm deploying one agent across multiple languages, and then I can add or remove languages as required, because the fundamental building blocks don't change. Another cool thing that can be done once you have this infrastructure is you can have an agent that can switch languages throughout the conversation. So some speakers actually do need that. They need to be able to, they are used to expressing themselves in various languages. So they need to be able to switch halfway through the conversation between one to the next. And it's something that our agent can support. And just to give you an example or an illustration, I think it's quite funny. We had someone from our team call and speak to our agent in Spanish, Chinese, and Mandarin, and English.
How can I help? ¿Cómo puedo acceder a mi cuenta? Puede acceder a su cuenta y realizar un pago utilizando nuestra aplicación para iOS o Android. 我的网络服务从昨天就无法使用了，你可以帮我一下吗？没问题，我可以帮您检查为什么该服务被禁用。首先，您的电话号码是多少？Sure, my number is 0935764892. Sorry, that didn't seem right. Please tell me the phone number on your account. 0935764892. And the name on your account? My name is Emmanuel Sefrin. Finally, what's your date of birth? 我的生日是1986年11月6日。
Great. So you see, again, our team members speaking in different languages and the agent being able to recognize the language and adapt to it. It's just a fun feature. I mean, some people need it. In general, it's also enjoyable to play with if you speak multiple languages. And again, it's just permitted by the fact that you have the core language agnostic infrastructure, and then you can build off on top of it. So I'll summarize by talking about the main elements that we see as the best practices when building a multilingual infrastructure. The first and foremost is really the ASR, the language, the automated speech recognition system that Ivan talked about. Voice deployments live and die with the ASR. And if your ASR doesn't work well, you can have the best engineer in the world, you're still going to struggle because you're not going to get good input from the speech recognition software. And so what we found that worked best was to combine in a smart way multiple ASR models, depending on the context, depending on the accent, depending on the specificity of the ASR model, combine multiple ASR systems and try to get the best of each of them to be able to optimize your chances of recognizing what the users say. Again, this is critical for all voice deployments. It's even more critical for multilingual voice assistants. You want to have as strong of an ASR as possible, and ideally you want to be able to combine multiple ASR systems to be able to maximize your chances of adequately understanding the user. Second, slightly less important, but not so, but still quite important, is obviously the NLU. You want to have a strong NLU, and a strong NLU means something that can recognize noisy, slangy, inaccurate data. We see that customers, when they contact their customer service, they typically express their issues in all sorts of ways. Sometimes they have a deep technical knowledge and they go straight to the point. Sometimes they don't know much about the issue they're facing, so they just use approximate text. They don't know what their router is, for example, so they're just going to say, I don't have internet, or the box doesn't work. They're going to use like approximate language when describing the issue. And then sometimes they're just going to use slang or poor text to be able to express the issue. So you want to have an NLU that's robust enough to be able to capture and understand any of this and react accordingly for whatever way people are going to express their issue. Third, again, you want to have a language agnostic but still quite flexible policy infrastructure. So policy is the most language agnostic of all, but that you still want something that's really strong and really flexible so that you can enable people to go back and forth and ask questions throughout the flow, and you want people to be able to go back in the discussion, which is something that not all policy flow enable. So even though you really want to have first on priority is like ASR and NLU, you still want to have a strong policy setup so that you enable people to navigate through the flow smoothly. It's even more important with voice than with text because people are just used to saying specific things over the phone, and you want to be able to accommodate that with the policy as well. So yeah, those three elements, again, in order of importance, I would say: one, ASR and the ASR infrastructure; two, the strength of the NLU; and three, the policy setup. And then ideally you have this whole package that can learn and improve with actual data, as we saw with the 2 weeks difference. And like once you have all this infrastructure, you can deploy something relatively easily. You don't need like a lot of pre-existing data. You just need a set of intents that you can learn from and a general conversation flow, and then you can deploy an agent in that context. Great. That summarizes the first part of the webinar. So I'll now go into questions. So if you have questions, please share them in the Q&A, and we'll try to cover as many of them as possible during the discussion. All right. So I'll start with a first question. Does the ASR first perform some language classification before decoding speech to text? And the answer is yes, as we discussed. So our agent does perform some language classification before decoding speech to text. It's not a must-have. You can do it without having this language classification if you know what language the user is speaking. But if you're really in a multilingual context and you have a context where you don't know exactly what language people are going to say, it really helps to have a layer of language classification before you know which ASR systems to run. And even if you're in like one language, it also helps to have some form of classification because, again, people might speak in different accents, or they might face different issues. And depending on the issue they face or the part of the conversation, you want to be able to adjust your ASR system for the right context. So you might not want to run. You might want to run a different ASR system if you're, for example, collecting digits from the customer, or if you're trying to generally categorize the intent. And it helps to have like some form of intelligence around this in the beginning. All right, second question. Do you have any experience building voice assistants in the hospitality industry? Would you need lots of data from us to train it? Great question. Yeah, hospitality is one of our top industry that we deploy agents in. We have an agent that can help people basically make reservations at typically at restaurants and hotels, and it really helps the staff in those contexts because they typically are too busy to be able to serve the existing demand of customers on site to be able to then answer the phone and also take reservations. So this is a typical use case that we see a lot, like managing reservations and just managing appointment scheduling time. And typically an instance of that is in hospitality, and we see a lot of demand in that space. Again, the beauty of the fact that we have already pre-train those agents and pre-train those intents means that we don't have to retrain it on top of it, and so we can just start from the get-go and learn really fast. Okay, third question for Ivan. What kind of pre-processing on Reddit data is needed to make the model distinguish languages? Or is it all encoded in the same hyperspace, therefore being able to find similar words in different languages with, let's say, cuisine similarity? And then greetings from Croatia.
Okay, so actually we follow something that is also used in other cutting edge research. For example, if you're familiar with multilingual BERT model and XLMR, so the idea is basically to blur these language differences and have like a shared multilingual vocabulary and just let the model to figure it out itself. So what we also found is that, yeah, we can slightly improve the model if we further fine tune it, like from a fully multilingual model to a particular language by just using the data of that particular language, which also kind of makes sense because then you're biasing your shared vocabulary to better represent that particular language. But in essence, the idea is to have this shared multilingual hyperdimensional space where all these different sentences can be encoded no matter what language the user actually speaks. So that's the idea.
Great, thanks, Ivan. A question for Anita. What advice would you give to create great customer experience across multiple languages?
Yeah, that's actually a great question. So first of all the heads of the customer services should provide a detailed list of intents, so to speak, because we should see what is the uniformity here. And usually in the telco industry, across all NatCos, across all languages, we have the similar intents. As per any other industry, we have a pattern that is recognized. So firstly, we go through each and every intent that is needed to be covered. And then we see what are the resources that we can actually use for each and every language. So some are high resource languages, some are not. And for those that are not high resource languages, we go through any internal transcripts or anything that they can provide us as a telco that we can actually use and train the chatbot model, and also provide the expectations when it comes to the training of the chatbot and everything. So also managing expectations throughout all these different countries is very important. That in some countries, in some languages, we can very much easily establish a solution, and in some it would need a little bit more of time. So it definitely needs a different model of addressing all these different languages when it comes to communicating how this solution would actually help the end users. So it is not just looking at the solution from a very high overview, but also going into each and every language and providing a good customized expectation for how the solution would actually look like to the end users.
And I think there is also an element of like monitoring and following up once you deployed something, right? Anita, do you want to say a few words about this as well?
Yes, definitely. I mean, after something goes live, it should be maintained. And also, when it comes to that, the good communication with all the countries should be maintained, that, okay, the solution is not final, that like the first version we would go live with it, but actually build on top of it and maintain it constantly. So yeah, definitely that is the second point once the solution goes live. Yeah.
Yeah, it's a point that we see a lot. Like you know, once you deploy, you still wanna. We see a lot of. We see the best companies do that. Like, and we work with them also. But it's like, how do you keep paying close attention to how people interact with the solution and where are they confused, where are they really understanding, and how do you adjust your agent to be able to really to really respond best to actual customer feedback. And this is where I think the speed of deployment, you want to choose some, you want to have an infrastructure that enables you to train and iterate quickly, because you never exactly know how customers are gonna ask questions, how they're gonna respond to specific prompts. So you want to be able to respond quickly and adapt very quickly to actual user data to be able to end up with a stage where you have a great customer experience. What's the best way to make the voice assistant representative of my brand globally? So this is a question that we see a lot. It's also a question that we get a lot from many companies. Like, how do you get a voice assistant that really support the brand image and not, just complement the brand image or support it instead of going against it. And it typically, I mean, there is a lot of love and care that can take place with the selection of the voice assistant, with the selection of the audio that you're selecting, the voice actor that plays the audio prompt. And I know we know at PolyAI we spend a lot of care into this because it really is the main thing that people will hear and the main thing that people will react to. And so you want to choose a voice actor that is able to have a warm, friendly voice that comes across as conversational and natural. Definitely not someone that would speak too formally or too in too much of a robotic way. It needs to be felt for the customer as if it was actually someone casually speaking up the phone and politely, but still normally just answering them, as opposed to having a formal agent, a formal robot just answering the phone. And if you do that well, then you really support your brand image, because it contributes to the image of providing a great customer experience in the phone, even when you have a digital assistant answering queries. Is it mandatory to fix the number of intents for any domain? So a number of you guys also asked this question. Ivan, do you want to take that one?
Yeah. So I can quickly say a few sentences about it. So basically, yeah, we having the desired behaviors and maybe some data from the client definitely helps us to kind of extract those intents. But having it as mandatory is not it's not mandatory. But of course, knowing the intents is helpful. And we are currently working on a solution which have like a more fluid set of intents, where you can switch off some of the intents during the use of the system to have it in a more flexible way. But yeah, I would say it is not mandatory, but it's not useful. I know, Emmanuel, if you have any slightly different viewpoint on that, because you're often at the forefront of getting the data from the client and then figuring out the intents.
Yeah, it's definitely something we can adjust later on, and we need to adjust, because again, typically during a live deployment, you realize there are new intents that you did not anticipate. So they could include people asking for clarification, people asking for more time, people saying they don't have the required information. You always make a plan, and then the plan is always changed when you're actually really deploying. And that also goes through the intent model. And so you need to be able to add new intents as you go through the real iterations after a deployment. Customers will always have a range of reactions and a range of issues that you might not have anticipated. And again, you want to be able to serve those as well. Some of those, like we did a deployment in a troubleshooting case. So people calling because they had no broadband, people calling because they had connection issues. And we asked them to perform a number of checks on their own. So try to restart your router, try a different cable, etc. And again, you deploy that, and then you realize people say, well, I'm not on site, or I don't know how to do it, or I forgot the exact list, but like there were definitely a number of reactions from customers that we had not anticipated and we need to adjust for. And then we also ask people to describe us the router lights to be able to then refine the diagnosis and being able to know exactly what was the issue that people faced. But when you ask people for the type of router, you want to be able to process again a wide array of responses and ways that people will describe it, and that might need adding new training data, that might need adding new intents, that might need merging a few intents. You want to be able to have an intent list that can be dynamic and not set, definitely. Okay, a number of you guys are also asking how many languages can you deploy for one company? Is it as many as needed? And the answer is yes. Again, the beauty of having a language agnostic infrastructure and a language agnostic kind of base with the policy and the NLU, and then on top of it, having language specific ASRs that can be added and removed easily, is that you can very easily add or remove languages that you support. And so for us to deploy something in 5 languages or 10 languages is a relatively small difference. There are typically, though, implications in terms of the operating model and when you deploy. So again, if you want to provide great customer experience, and we definitely do, and most of our clients do as well, you want to be able to closely review and monitor the performance with live data. So you want to be able to closely view how customers respond to it, what questions do they ask, how do they interact with the experience, and that means that you have the resources to be able to analyze the data, listen to the calls, provide feedback in any language that you deploy. So again, if you were to deploy something in 10 languages, it would mean that you need people who speak those 10 languages, who can review the calls in those 10 languages and can provide feedback on it. And we have a number of those resources, but typically it's also a challenge for the companies that we work with to be able to find those resources. But from a technology perspective, it's not an issue. You can add or remove as many as you need.
Yeah, so if I can just quickly add, so the beauty of this design and what we actually try to convey in the webinar is exactly the fact that expanding our spatial language understanding methodology to many different languages is pretty much the same as working with a single language, because it's just a generalization of this idea of capturing the semantic variability, unconstrained ways of how people speak to the system, and you can see it as having paraphrases in a single language, or you can see it as having sentences about similar things in many different languages. And then, yeah, there are these additional challenges, how to optimize then your entire system for every single language to get like the stellar customer experience and all that. But as Emmanuel said, from a technology perspective, yeah, there can be many languages supported. So yeah, there's almost no extra cost on the language understanding side.
Great. We also have multiple people asking about the about the 10 days. So what does the process of 10 days actually look like? And if we started today, what would happen? So typically, like the 10 days is used for the policy design and the intent mapping. So really, the beauty of having some models that are pre-trained is that you need very limited data to start with. So all you need is really a list of intents that you should expect. And again, it can be done in a dynamic fashion, so you can start with a hypothesis and then build off it. But most people already have an existing list of intents they expect to anticipate, and this really helps get started, as well as a draft policy flow. So how do you respond to the different use cases. What is the expected policy that you have? And then, typically, like, once you have this, it takes just a few days to build a first version of the agent, and then you can deploy and get real life data. And again, the 5 days of deployments, like I would 10 days, I would split 5 days in building a first version and 5 days in iterating through the data. And the beauty of 5 days of having real data that you can iterate on means that you can just improve the performance of your agent significantly. You can improve just the raw performance in terms of NLU, in terms of ASR, but you can also improve the quality of your customer experience in terms of the questions you ask, in terms of the ways you respond to different kind of issues, in terms of the anticipation of some challenges that people will face. You can adapt your policy based on real customer feedback. And so 5 days of iteration is really useful to be able to refine and tinker around your customer deployment. Your live deployment. Yeah, this is how 10 days would fit. It's again, it all comes down to having something that is flexible and can be quickly iterated, because then you can really easily adapt to a lot of different use cases. Okay, we have also a question about, do multilingual capabilities work across other industries? Ivan, do you want to take that one? What are the industries that you see those capabilities being deployed?
So not only conversational AI. I mean, I would say that multilinguality is a very fundamental block of any like text-based or voice-based industry that needs language in any form. So you can think of, for example, I don't know, market sites that have multilingual capabilities. So people should be also able to like, I don't know, write product reviews or browse products in their native languages. And in order to support that, you kind of have to have I don't know, multilingual sentiment and analysis deployed as for example one part of understanding how people think about your products. And of course, when we talk about multilinguality, machine translation is one of the core businesses that yeah, I mean it's essential. Also, like if I have to think about another example. Yeah, I don't know, like web search as well is also, we need multilingual solutions so that people can actually browse the web in their own native language and still get relevant examples from maybe from a different language, which can then be translated for that. So that's like the main idea behind cross-lingual information retrieval and multilingual information retrieval is to expand the set of possible documents that you can retrieve as relevant to the user's query. And it also requires multilingual representation. But conversational AI is probably one of the, if not the holy grail of these applications, to be honest.
Great, and I think that wraps up our session today. Thank you to the panel again. Thank you so much to Ivan and Anita for joining us in this discussion. If any person in the audience. Sorry, now there is an echo. If any person in the audience has a follow-up question, please don't hesitate to send an email to Maria. That's maria@polyai.com. Please feel free to reach out with any questions or any comments. We're very happy to hear feedback. And I wish everyone a great day from wherever you were dialing from. Thank you.